Thank you so much. Thank you all for joining us on the call today. This is a media telecon to address some questions with Starliner. On the call today, we have NASA Administrator Jim Bridenstine, Jim Chilton, Senior Vice President at Boeing Space and Launch, Douglas Loverro, Associate Administrator for NASA's Human Exploration and Operations Mission Directorate, Kathy Lueders, Program Manager at NASA's Commercial Crew Program, and John Mulholland, Vice President and Program Manager for Starliner Program. They will each provide opening remarks, then we'll open the line to questions from reporters. So with that, we'll turn it over to NASA Administrator Jim Bridenstine.
Hey, I just want to thank everybody for being on the call today. Today we're going to discuss some of the anomalies from the OFT that happened here back in December. I want to start by saying that we have an independent review team that is still in the middle of an investigation. That investigation is scheduled to be complete at the end of February. It is very unusual for NASA to kind of do a press conference about what the investigation results are as the investigation is underway. But in the interest of transparency and some of the things that I saw online yesterday, I wanted to make sure that everybody knew kind of where we were in the investigation. Clearly, we are going to continue to learn more in the weeks ahead, and we'll have a lot more information to share at the end of the month. It's also true that we do think that the OFT flight had a lot of anomalies, and we're going to talk probably a lot about some software code today. But it's also true that we need, as a nation, we have an obligation to have multiple providers that can get us access to low Earth orbit. That's part of what the Commercial Crew Program is all about. And we are working very hard to understand what the anomalies are, remedy those anomalies, and move forward. So with that, Bettina, I'll turn it back over to you, and we'll have some other folks, I guess, put forward some opening statements, and we'll get into the questions.
Yes, thank you, Administrator. With that, I'm going to turn it over to Doug Loverro.
Thank you, Bettina, and welcome everybody to the teleconference today. I just want to provide a couple of high-level remarks about the issues that we're dealing with here so that you can all understand where we are at. And then I'll turn it over to Kathy Lueders after I'm done, who will go into some of the more detailed technical issues that I know you all have questions on. Let me start by saying that, as the Administrator's already said, we are in the middle of our independent review. But we did have an interim outbrief last Friday specifically, a week ago, and I'm happy to say that I think they did an incredible job of telling us what the size and shape of our issues are. And to put it bluntly, the issue that we're dealing with is that we have numerous process escapes in the software design, development, and test cycle for Starliner. The two software issues that you all know about, and to a lesser extent, the hardware issue on the antenna, which we'll talk about as well. But the two software issues that you all know about are indicators of the software problems, but they are likely only symptoms. They are not the real problem. The real problem is that we had numerous process escapes in the design, development, test cycle for software. And as we go forward, that is what we're going to be concentrating on, is how do we assure ourselves that all of the software that we've delivered, not just the two routines that were affected by these issues, are fixed. So we test in order to go ahead and find out if we've done our job right. What this test revealed is that we had specific problems. By having the independent review team look at these specific problems, it told us that we have a more fundamental problem, which is what we briefed the ASAP team yesterday and the day before yesterday, and is what led, and we told them what we were going to be doing in response, which is what they then reported to you. So we're happy to go ahead and go into the details of that But I just wanted to kind of put this in perspective. It's not just the specific issues that we discovered in this flight. It's what we discovered by the independent review team, which is numerous process escapes. And with that, I'll let Kathy talk about the specific issues that we found here.
So, as program manager, the best outcome is when you find a problem, as we found as we're heading up on that Friday, is to be able to quickly find the source and then begin the process to fix it, right? As Doug said, we've been very impressed with the joint team, completeness so far. They're still in work, as Jim had talked about. Both teams, both NASA and Boeing, have been open to the review team. And because of that, we've been able to quickly assess and find where the error was made, at least on those two software areas. And I'll talk a little bit more about that. First, for the mission event timer issue, every spacecraft, it starts, there's a 0, and it ended up finding out we weren't able to make orbital insertion burn because we ended up finding out that there was an issue with the way a software requirement had been implemented. And for that timer to have been implemented correctly, 2 conditions needed to have been met. And only one was sufficiently coded in the software. And so because of that, we now have to go look at why wasn't that coded, why wasn't it caught in our testing. And so it's something that both Boeing and NASA will have to work together on. In addition, the service module disposal, while we were really evaluating and getting ready for reentry, we found out that the way the firing sequence for the service module for disposal had been coded similarly for free flight. And what it should have been coded, where it should have had a separate lookup table that really defined a firing sequence for a disposal burn. And so that was another place where there was a coding error. This time, because of the testing we were doing to really make sure that we were clearing up any issues during the mission and making sure we had a plan for a safe reentry, we ended up finding that one, updating a new mission data load, and being able to fix that error, and then obviously had a very successful reentry. And John will talk more about that. I think this just continues to show that we need to be vigilant. I know John and I, as a team, will take what is the interim findings out of the review team, and we're already putting together corrective actions for the interim findings, and we'll continue to take the lessons and the items that they are bringing up in their very thorough review forward and continue to get better. Thank you.
So with that, we'll turn it over to Boeing's Jim Chilton.
Thank you, Bettina, and thanks everybody for your interest. As we've talked a little bit previously, this flight test taught us a lot. You test to learn. Somewhat, one of our surprises, you're always surprised by what you learn. You often wish you had gone through your design process differently, and we certainly are going to have some hardware opportunities coming out of this, emerging out of data review, and the independent review is also looking at some of the hardware findings. But in this case, what we wished we'd done better was software. So there's a lot of learning there. I would like to say that we have, in the month of January, while the independent review team was doing their job, we've been doing hardware inspections and data reviews. That also feeds our forward plan. That's work that Boeing and NASA do together, separate from the independent review team. And, of course, during that time, while we're doing that work, we don't have a lot of interaction with the independent review team. I mean, we don't want to influence them in any way, so I'll emphasize the independent nature. We got our first view of that last Friday along with NASA. That's when we got our briefing. And I echo Doug's comments. I think they have done an excellent job and given us things in actionable chunks that we know we'll be able to put into a forward plan. I'd like to talk about the second software a little bit because I perceive that there's curiosity and some hey, why didn't you tell me more? So I'll just I'm going to tell you the whole story. As I mentioned, on the first day we had our ascent challenge and the software error. We got the spacecraft to an orbit where we could begin to say, okay, what's the rest of the mission look like? I think I mentioned at the first press conference that we would have to go look at all the software required to continue flying and bring that spacecraft home. We did that. So the message there is we went hunting for comparable software errors. We had found we had a susceptibility, and we said, okay, even while the spacecraft's up there, we got to turn the team on to go find anything that similar that we could be susceptible to. We found one. We found it because we went looking. It's our belief that we wouldn't have found it if we hadn't gone looking. And I think that's been the subject of the ASAP report that came out yesterday. I'm not privy to the ASAP. So the bottom line is we went looking for things. Our initial error was we made a mistake in how Starliner reaches into Atlas. Think of it as an integration challenge. We went looking for similar ones, and we found one where the crew module and service module have to work together. After the crew module separates from the service module has to go be an independent spacecraft and get rid of herself. We believed that the way the software was going to do that could have resulted in the service module bumping back into the crew module. That concern is the source of the ASAP comments in our view, and I see Doug nodding, so he is in agreement. You were there, I wasn't. We didn't go do a comprehensive analysis of the effect of that. It can't be good when two spacecraft are going to contact. So we immediately went and uploaded, we went and worked on software that we could upload before returning to Earth. That, just for full disclosure, we went looking for software. We found something wrong. We don't think we would have found it if we hadn't gone looking during the mission, and we didn't like what could have happened, although it was more important to us than to prevent that happening than to go deeply analyze what could have happened. After all of that, in the software realm, we handed that off to the IRT and said, you better look at all the software and how we got here, and we stand by for their report, but also what NASA chooses to do with their report. So what we'll do going forward is we'll let the IRT finish their work on both hardware and software. We'll ingest what they recommend and whatever NASA does in other forums, and we expect that NASA will have more to ask us to do than just what the IRT says. We'll put that in a work plan, a schedule, and we'll ask for NASA approval. We'll say, hey, do you see this as a reasonable course of action going forward to make this a worthy crew vessel for you? And then only after that will we be able to say kind of what we would do going forward. But number one was a test flight, and we learned more about our ground software process than we wanted to, but you test to learn, and so we're happy about that. Number two, we went hunting immediately after our first software problem, and we found one. Full disclosure, and I don't think we'd have found it if we hadn't gone looking right after that first one. And we fixed what we found. Now, I'll leave it to John and Kathy to get more into the technical details as people are interested, but I will finish by saying I want to thank the independent review team for they did a lot of work in a month when you look at that briefing. And rather than give us one or two big broad things, they gave us lots of actionable, do this with some specificity. I want to thank them for that. I want to thank NASA for, you poured a lot of smart people into this to help us get better. So I'm grateful, and we're going to just continue our ground software test till we know we have this right. Thank you.
Thank you. And lastly, we will have John Mulholland for his remarks.
All right. Thank you very much. So first, I'd like to say that nobody is more disappointed in the issues that we uncovered in the OFT mission than the Starliner team. But to a person, they're committed to resolving these issues in partnership with NASA and the IRT and safely returning to flight. So I'm incredibly proud of the professionalism and the resilience and the dedication of the entire integrated team. I'd like to talk just a little bit about some of the details of the two software issues. The first on the mission elapsed timer. The requirement that we have to pull that time from the launch vehicle is to allow propagation of that time and to have the initiation of the orbital insertion burn after we separate from the launch vehicle at the correct time. When we pull that time, the requirement is for us to pull that mission elapsed time from the launch vehicle only during terminal count. That is when the launch vehicle establishes and codes in the exact launch time. If you pull the time before that, there is a time that's in there, but is not correctly mapped to the right launch time. And so our requirement was to have both of those conditions met. So we pull the time from the launch vehicle, and then we pull it after the initiation of terminal count. Unfortunately, the software was coded and missed that second requirement, that it be pulled after the initiation of terminal count, and so it pulled an incorrect mission elapsed time from the launch vehicle, which then gave us an 11-hour mismatch between the correct time that we should have initiated the burn, and so that burn was not correctly initiated after we separated from the launch vehicle. The second problem that Kathy mentioned was the valve mapping error that we had for the service module disposal burn. During what we call free flight, when the crew module is attached to the service module, there's a certain valve mapping, and the flight computers on the crew module command all of the individual thruster firings. But after you separate the launch vehicle from the crew module, the propulsion controllers on the service module have to conduct those thruster firings to get the proper disposal, separation and then disposal burn. That valve mapping is different in those two cases, and the software, unfortunately, had the same valve mapping for both of those conditions. So we had an incorrect valve mapping for the separation and disposal burn. So we detected that, as Jim mentioned, when we went into the lab during the flight, conducted the verification test with the flight propulsion controller. It exhibited that issue. The team very quickly recoded the software, re-verified it in the labs, and we were able to upload that software correction and safely complete the mission. The third issue that we have the independent review team looking at, as Kathy and Doug mentioned, was the problems that we had in our space-to-ground communication, what we call our forward link, that allows the ground to talk to the spacecraft through the TDRS software. Unfortunately, during this mission, over some specific geographic footprints, there was a very high noise floor, and that high noise didn't allow us in a timely manner to establish that forward link with TDRS. And that was important because that happened right after we separated from the launch vehicle, detected that we didn't get that initial orbital insertion burn, and it took us several minutes to actually establish that forward link and get a new burn uploaded to get us to a stable orbit. That issue would have exposed itself whether we had conducted a fully successful mission or not. Again, getting back to why we test, and so we have the IRT has not finished the analysis and testing associated with that to give us specific recommendations. They're out with the supplier of the transceiver doing testing in the labs, and fully confident that they'll uncover the exact root cause and give us firm corrective action. So we're eagerly standing by waiting for the conclusion of that. And that's all I have. Thank you.
Thank you so much. With that, we're going to start taking questions from members of the media who are on the line. I will ask members of the media, please, we have a lot of questions. If you can each ask just one question, please direct your questions to the person that you want them to answer. With that, we're going to take the first question. We're going to open the line. Marina Korn.
Hi, thanks for taking my question. This is for Kathy and John. So the software issue that you've identified that would have interfered with the service module's separation from the capsule, can you please walk us through step by step what would have occurred if that had failed during the mission in December?
I think, what Jim was talking about before, right now it would most probably have caused the two vehicles, the service module and the crew module, as they were separating, you potentially could have had contact with the two rather than separating cleanly because of the firing sequence of the thrusters.
what does that mean, have contact? Sorry.
Go ahead, John.
Excuse me, could you repeat that?
Sure. What would have happened if the software issue that with the service module separation from the capsule, if that failed during the actual mission in December, what would have happened?
So first, I'd like to point out that we design all spacecraft separation sequences so that you do not have recontact or two spacecrafts bumping into each other. And so at the time when we discovered that we had that potential, our complete focus was on ensuring that we had the correct software upload to prevent any potential bumping or recontact. What you worry about on any spacecraft is imparting any rates if you bump into each other and or causing some damage. But our focus was to just fix it and come on.
But what would have happened? I just wanted to get that question answered. What would have happened? The worst case scenario that fails, spacecraft bumping into each other. For a regular person, that sounds dangerous.
This is Jim Chilton. The thrusters uneven firing would cause the service module, which is a piece of a cylinder, to come away from the crew module and recontact or bump back into it. The bad things that can happen then is John mentioned in part, that means you go poke the crew module and it gets unstable and it has to go stabilize itself. So one question is, do you hit it hard enough to where it tumbles or you have a problem? Another thing is you don't want to damage that heat shield because you need the heat shield to come back in. Where, it's hard to say where the service module would have bumped, but nothing good can come from those two spacecraft bumping back in. So we sent the software to make sure that couldn't happen.
I think it's important to note that we really don't know what would have happened. What we do know is that we changed the software, and because we didn't know, and when we changed the software, we had a really good idea that it wouldn't bump into it, and that's really what this orbital flight test is all about.
Thank you. We'll take our next question. Will be Irene Klotz. Irene?
Thank you. My question is for Jim Chilton or John Mulholland. Can you give us a sense of the scope of how much software is going to need to be studied? And perhaps even, I don't know how you can characterize that in terms of time or lines of code or different systems that are going to be impacted. And since this is a different kind of contracting arrangement, is this something that is Boeing intends to fully fund on its own dime, or will it be going back to NASA to see if there's additional funds available? It's just kind of hard to get a sense of the scale of this.
Yeah, Reed, I'd say that based on those two issues, we believe that we need to go back and re-verify all of the flight software code. We just received the corrective actions from the IRT. My team right now is going off trying to lay out the detailed plan that we would propose to go re-verify all of our flight software requirements. We'll be getting with NASA and the IRT to make sure that they agree that with our planned actions, and we'll be working that together.
And Irene, it won't just be Boeing, right? It'll be Boeing and NASA together about what are we going to need to do, even from our processes, to go look at and upgrade what we need to do to work with the Boeing folks on this.
So how many lines of code are you talking about, or how long did it take to develop all of this?
Through a development process, it's obviously iterative. The spacecraft has approximately 1 million lines of code. So we exercised on the OFT mission successfully about 66% of the scripts that we have. So that, but we're not taking that at face value. We are going to have our team go back and fully verify the correct implementation of all the software requirements in partnership with NASA.
Thank you.
Thank you. Our next question is from Joey Roulette.
Hey, thanks for doing this. Question for John Mulholland and Jim Chilton. How many, kind of similar to Irene's question, how many lines of code, I guess, was written to fix the service module software issue, and how long did it take to finish that? And then one question for Jim Bridenstine. I was wondering, what were the results and findings of the previous, more limited organizational assessment of Boeing? And if that review had not been so limited, do you think we would, be experiencing as many software bugs as we see today?
How long did it take to do the...
Oh, excuse me. So, yeah, with the, on Saturday evening, as we were going back and re-verifying all the software code, as Jim mentioned, they discovered it late Saturday night. This actually was a pretty simple coding sequence, so it didn't take the team very long at all to correctly recode it, and within a couple hours they were able to recode it and run it back through the verification, and then we were able to upload it on the spacecraft.
As far as the safety assessment goes, Kathy, I'll kick it over to you since you were kind of leading that.
Well, I think what's key is that we went in and at the time did a focused review of the Boeing corporate culture and what they were doing, and they're put in to address the concerns we had when we were working the original organizational safety assessment, which was really started about a year ago, right? We are now working with Boeing on how do we address what may be potential new areas for us to work and assess and see if there's any other areas we need to get beefed up before we go into our crewed flight test. This is an ongoing thing when we're working, obviously, with each of our providers, that if there's areas where we think we need new focus, and as we move forward and are learning, we'll address different areas. And so I think this has been, because of the issues that we had, we want to just make sure that we're kind of covering all the bases to get ready for crewed flight.
And what were the findings of that initial corporate assessment? Was it positive? Did you see anything questionable?
Hey, Joey, this is Doug Loverro. So I want to make sure we answered your other question first. So the purpose of an organizational assessment isn't to go ahead and find code errors. So there are two different things. You're trying to find out what the overall culture is in an organization. It's impossible to say if we had done a more complete thing whether or not there would have been any indications of this. So I don't think you should at all equate the depth of the organizational assessment with the discovery of code errors. You do coding in an engineering technical sense, and the organizational safety assessment is there to find out if you have any other kinds of issues. Doesn't mean you wouldn't have gotten some hints of it, but I don't want to connect those two in anybody's mind.
But I do want to answer the results. I mean, we went through, we did the assessment, and we did not find any unsatisfactory results at that time in the focus areas that we looked at. But we also didn't conduct a full organizational safety assessment. We did kind of a focused assessment of key areas with the Boeing team.
Thank you.
Thank you. Our next question will come from Eric Berger.
Question actually about the antenna and the communications issue that John Mulholland talked about a little bit. Was this in the S-band? And I ask that because I'm wondering if this would have posed a problem if you were able to go up to the space station I understand that that's a fairly noisy environment, and if you already had sort of self-generated noise or problems with communications, I'm just curious, theoretically what might have happened and if that issue might have prevented a docking as well.
You have, we have two communication systems. One is space to ground, one is space to space. So as you get closer to the International Space Station, we have a space to space communication system. At a higher altitude, you wouldn't be susceptible to that same noise floor that we saw over those specific geographic footprints. Obviously, going forward, as we look at all of the software, we'll be going through to make sure that we test all of the sequences we were unable to test in the uncrewed flight test, including rendezvous and docking.
Okay, so just to be clear, the noise issue then, which I don't fully understand, that was not something generated by the spacecraft itself. That was something due to the just terrestrial environment.
What we believe in, and I'm not trying to avoid the question. I'm sorry. I just want to make sure the independent review team is able to go conduct their full assessment. Right now, we believe that it was based on noise from Earth-generated noise over specific geographic footprints is our early preliminary indication. But obviously, the IRT needs to complete their full assessment.
Understood. Thank you very much.
Thank you. We're going to take another question now. Just seeing the chatter on Twitter, if each of the speakers can announce who they are when they answer the question, just to help the reporters, that would be helpful. So our next question comes from Jackie Waddles.
Hey, folks. Thanks so much for doing this. So to follow up on the communications issue, I just want to make sure I understand what exactly could have been the noise interferences coming from the ground? What could have been the potential source of that? And then was there an issue specifically with the antenna? Yeah, that's it.
Yeah, we believe the frequency.
Identify yourself.
Oh, I'm sorry. This is John Mulholland. We believe the frequency is associated with. It's very close to the frequency that would be associated with cell phone towers, and that created that high noise floor, which didn't allow us to establish a link as soon as we would have needed to, and it caused us several times to have delayed ability to link with teachers. And the second part of your question was antenna issue. Oh, there was no. I'm sorry, there was no antenna issue that we have seen yet. But obviously, that review and testing is still ongoing.
Got it. Thanks.
Okay. Our next question comes from Marcia Dunn. Marcia?
Yes. Hi. Thank you. If I could get a little timeline, how many hours before reentry was the second software error found, and how many hours before reentry was the fix finally put in place to allow for a safe landing?
Let's see. Yeah, so from a timeline perspective, we landed approximately 48 hours after we launched. The discovery of the software error was late Saturday evening. We landed about 7:48 Eastern Time on Sunday morning, and so that team was able to discover that problem late Saturday night, change the code, re-verify the code, and we uploaded it approximately 5 in the morning Eastern Time on Sunday morning.
Oh, wonderful. Thank you. And one question for Mr. Bridenstine. Given these latest and numerous software issues, certainly you must be leaning toward a repeat of an uncrewed test flight. Could you speak along those lines?
Yeah, I don't think we're ready to answer that question. Doug, do you have anything to add?
Yes, sir, I do. So, you you don't go ahead and do flight tests to verify you've solved problems. You do flight tests to look at a holistic picture of the system. And so it's too early to say whether or not we'll want to go ahead and do another flight test. What we have to do is what Jim Chilton said, is we've got to go ahead and identify all of the process errors we have. We have to put together a work plan to make sure we can go back and find and fix all the process errors. We'll look at the completeness of that. Once we have that done, we'll do testing in our simulators. We'll do testing in all sorts of other places to verify the code. We'll obviously do much more verification than we did the first time. Then we will make a decision based upon what we find, because we don't know how many software errors we have. We don't know if we have just 2 or we have many hundreds. So based upon what we find and based upon our assessment, we'll make a call then. But we can't make that call now because we just have a lot of work to do before we can do that.
Okay, thank you so much. We'll take our next question. It's from Lauren Grush.
Hi, thank you for taking my question. I'm just curious, when did NASA know about this second software issue, and, is there any reasoning why it was delayed in telling us about it?
Were you addressing that question to anybody in particular, Lauren?
Yeah, to NASA, to you, Doug, and to Jim Bridenstine. Okay.
Well, let me answer that, and then the boss can correct me if I get it wrong. So the interesting thing is we didn't end up having an anomaly. We found an issue when we fixed it, right? So we knew that we had fixed it when we brought Starliner back. So there was no anomaly but what we knew was we had software issues, and one exposed itself in flight, the other one was found during analysis. But then we knew what we needed to do was to go ahead and put together a team to find out just which state we were in. So it would have been very difficult, Lauren, to go ahead and even have the discussion we're having today without having the independent review team go back and look at this. Had we had that discussion back then, we probably would have gotten it wrong. So I think it's not that we were not revealing something. Is we knew we had some issues. One that was exposed in an anomaly, the other one that we found in analysis, and we knew we had more work to do. So we didn't want to speculate on that at the time, and I don't think you would have wanted us to speculate on it and provide a false indication of what was going on. This is normal. During tests, we're going to always find things that are wrong, and our job is to test and find them and then fix them, and then at the end of the whole process, to let you know how we did. So I don't think I want to characterize it as something we didn't reveal, because it's really it's an issue that did not happen, and it's very difficult to go ahead and start speculating on issues that did not happen.
Okay, our next question will come from Ken Chang.
Hi, thank you. This question is for Kathy, Doug, and Jim. What went wrong with NASA's insight and oversight processes? It was not that you missed 2 bugs, but you seem to have missed the systemic weaknesses in Boeing software processes, and how was that supposed to show up? And going forward, you're looking to use a similar approach for much more ambitious projects for lunar landers. So how can you have confidence that you can do something like that if you can't get this right?
Yeah, this is Doug Loverro. So that's a great question. Thank you for that. So look, our NASA oversight was insufficient. That's obvious, and we recognize that, and I think that's good learning for us. So as Kathy's already said this, from her side, the independent review team didn't just have recommendations for Boeing; it's got recommendations for us as well, and we're going to take all those to heart. And I can absolutely guarantee you we're going to go ahead and make sure we apply this to the human landing system. I'm not going to be shy about telling you that we are going to have far more insight and oversight into the human lander system than we have had on any of the commercial crew programs, and not just because of this, but because flights to the space station are, as strange as it may seem to be able to say this, flights to the space station are somewhat routine. Flights to the moon are anything but, and I think we would all be incorrect if we assumed we could turn over such delicate and unusual operations to a very limited oversight method of work.
Thank you.
Thank you. Our next question comes from Marcia Smith.
Thanks so much. This is a question, I think, for Jim Bridenstine. I'm curious what kind of reaction you're getting from the White House and Congress. And had they been briefed on this before yesterday when ASAP revealed it to the public, or are they learning about it like the rest of us?
So the independent review team is still working. The investigation is still underway, and it concludes at the end of February. So at this point, as far it's really just the NASA and the Boeing teams that are working through these anomalies.
So have you heard anything from the Hill or the Space Council?
I haven't. I don't know if other people at NASA may have.
Sir, this is Doug. So we've gotten a couple of questions from the Hill now, Marcia, as a result of the news stories that came out yesterday, and we'll address them as we can.
Okay, thanks.
Thank you. So we're trying to get through as many reporters as possible, so we please ask you to limit to one question. Next reporter, we have Bill Harwood.
Thank you, guys. I'm a little confused about when the timer issue was first noticed. In other words, was the vehicle doing anything immediately after separation that indicated something wasn't right, or was it not until the orbit raise burn didn't occur? And finally, do any of you guys think, and regardless of whether an OFT2 is ordered or CFT is the next flight for the Starliner, is there any reasonable chance that one of those flights would happen this calendar year? Thanks.
So the full indication. Yeah, this is John Mulholland. Sorry, Bill.
John.
The full indication that we had an issue was after we passed the point where the orbital insertion burn was supposed to happen, and it did not. We got indications of it right beforehand as the vehicle was translating to a different pointing guidance, and the deadbands were collapsed that resulted in a significant number of thruster pulses. So we started seeing indications. At that time, we didn't have the RF link established with TDRS, and so we couldn't update a new burn timer until several minutes after we missed that OI burn, which resulted in a significantly high thruster pulse count and depleted the propellant supply to a level that wouldn't allow us, once we stabilized, to rendezvous and dock with the ISS. We will not speculate right now on any specific launch date. What we have to do is fully understand the scope of the corrective actions, implement that into a work plan, and once we get that scope defined, established, and partnered, we'll be able to evaluate a specific launch target at that time.
Thank you so much. Our next question comes from Jeff Faust.
Hi, thanks for taking the call. This is a question for, I think, John Mulholland. There's a reference to numerous process escapes in the software development and design. What sort of processes are in place? Are these NASA requirements that you have to follow? Are they internal Boeing processes? And if it's the latter, are these processes used elsewhere, either within Boeing Defense and Space or elsewhere in the company? Thanks.
Yeah, this is John Mulholland. So when we look at the overall software design and verification process, it's a pretty standard process. We obviously have partnered that plan with NASA, and it starts at the very beginning of the design phase when you are establishing all of the software requirements that you need to implement. And so it goes from software requirements to generation of code. At that point, you have a peer review of the code to ensure that, when checked, to make sure that you have written the code to the requirement. You go through what we call unit testing, which is small subscale testing of that code. And it gets implemented, and you run through a series of integration tests to test all the different parameters. And then at the completion of that, you enter what we call FQT, which is formal qualification test. So there are a number of checks along the way that are designed to uncover and correct code errors as early as you can, because the earlier you detect them, obviously the less impact it is to fix them. So in this case, when we look at our software verification process, we're looking at that end-to-end process. And obviously, at a minimum, these two code errors made their way fully through that process that was designed to detect and correct. And so we're looking at each of those work streams and identifying ways to make it more robust.
Hey, Jeff, this is Doug Loverro. So in the interest of full transparency, as the boss has said, so that process that John just went through is a very, very standard software process. What our independent review team found is that we had breakdowns in multiple areas in that process. Okay, for each of these two problems that we know about, some of that breakdown was in different spots, and some was in the same spot of the process. But we had multiple breaks down in that process. So the independent review team characterized it as here's where that error occurred. For example, on the mission effect timer, it's how we specified the requirement and made sure we had coded the requirement. And they said, here's the 3 or 4 places along the way you should have found it and you didn't find it. And that's how it ended up getting in the flight. So I want to make sure we give you that full insight that the process broke down in many areas for each of these things. And that's one of the reasons why we have to go back and do such a thorough review of all of the software.
Okay, thank you. Our next question comes from Michael Sheets.
Hi, all. Thanks so much. I want to take a quick look at this because I realize you haven't finished the investigation yet, and so you're probably going to back away from saying this outright. But it seems that there's no way to complete this investigation without conducting a second orbital flight test, uncrewed test. Will you perform a second one? This question, will you require Boeing to perform a second one? This question's for Jim and Kathy. And currently, if you can't answer that currently, what is the likelihood that you don't require a second flight test? Thanks.
So I think you're absolutely correct that it is still too early to know that. I think Doug articulated earlier that what we need to do is we need to understand the systems and the software and understand what the problems are, and then go forward and fix those problems. As far as whether or not we need another OFT flight, that's a decision that will be made in the future. As far as assigning a probability to that, I just don't think we have enough information at this point. Remember, we're still in the middle of the investigation, so I think we're very premature to make any announcements regarding that at this point. But Doug, if you have anything to add, I'll let you do that.
No, sir, not specifically the question. Although I want to characterize for folks who may not understand how we do development and test. If you have a flat spare tire, you don't find that out by driving the car. Okay, you find it out by opening up the trunk and checking the pressure in the tire. And not that anybody has spares anymore, I know that. So we have to understand where flight test figures in a test program versus where other elements are far more perceptive. And that's what we're going to be looking at, is where is the best way to have the perceptibility to find the issues we need to find. We will make that call on flight test at some point. But right now, our intention is to go check the spare and make sure it's got inflated properly. That's the most perceptive thing we can do.
Hey, thank you so much. We're going to take one last question from Tim Fernholz.
Thank you all for doing this. My main question is, what are the 11 corrective actions that NASA mentioned in its release? But I also have a follow-up for Doug on the question about the safety assessment. You mentioned that it's not really about the individual errors here, but the various process escapes. But you also said that the safety assessment shouldn't be associated with these problems. Why is NASA deciding to have the full safety assessment now in response to them if we shouldn't expect it to reveal any issues like that?
So this is Doug Loverro again. So don't misunderstand what I said. I didn't say that a safety inspection wouldn't provide insight into whether or not we have these kind of problems. I said that you don't depend upon a safety inspection to find these kind of problems. Those are two different things. Let me, if I could, just go ahead and tell you about the safety inspection. We actually made that decision before the independent review team had reported out to us, and it was many factors that led us there. But it said, it looks as if there could possibly be process issues at Boeing, and so we want to understand what the culture is at Boeing that may have led to that. This will be information that will help inform our go-forward plan. So we actually need that assessment now to better inform our go-forward plan on this. And I will tell you there were several factors that were in my mind when I asked the boss if we could do this. And those were obviously press reports that we've seen from other parts of Boeing, as well as what seemed to be characterized as these software issues, and obviously the OFT test itself. So it's not a direct one-for-one correlation between the two, but at this point we think it will be insightful for us to do that to help us understand just how the process errors that we just talked about actually occurred.
Gotcha. And can you talk to the 11 priority corrective actions that Boeing is going to undertake here?
Sure, Kathy will take care of that.
Yeah, and I almost, right now the IRT is still finalizing all of its corrective actions, right? So I want to make it clear that these are interim actions. Like we've said several times, the investigation is not going to be completed until really the end of the month. And we are actually going through our first round of actions. John and I are actually taking the initial round of actions, which address obviously the specific software errors, but also bring up and require us to go look at how we do testing of our software, what's the stressing cases we do to test the software, what are the different environments that we test the software in. Those are the kinds of things that are in our initial set of actions. We're going to take those actions along with further actions that Doug and the EO team they have given us to make sure that we're really addressing root cause. Why did these things happen? And over the next few weeks, we're going to be meeting as a joint Boeing-NASA team along with agency leadership to make sure that we, between John and I, are really addressing the root cause and identifying the key things that we need to go fix before we go fly.
Well, thank you so much, Kathy. With that, we're going to conclude our call. I'm going to turn over the line to Administrator Bridenstine for closing remarks.
Thank you, Atina, and thank you for everybody participating in this phone call. Just in closing, I want to make sure everybody knows We are 100% committed to transparency. We are in the middle of an investigation. The ASAP had a public meeting about this issue, and now we're sharing as much as we know to share at this point. I have also directed, and I want to say to all of the senior leaders at NASA that are on this phone call, I appreciate your transparency. Before the phone call, I directed everybody to be as transparent as you can be, and also to never, ever, ever be afraid of the truth. And that's the direction that I gave them, and I think that's what we have done today. And I also want to close on one last thought, which is the commercial crew program is broader than a single provider, and that's intentional. We have two providers, SpaceX and Boeing, that are going to take American astronauts to the International Space Station. And this program, because we have dissimilar redundancy, this program is going to continue moving forward in a way that will make our nation proud. And it is our commitment to make sure that we do have dissimilar redundancy into the future, which is a big part of the success of this program. So, Kathy and Doug, thank you, and I'd like to thank the Boeing team as well, Jim Chilton. And with that, Bettina, I'll turn it back over to you.
Well, thank you so much, everyone, for participating on this call. This concludes our telecon with the media on this matter. If you have additional questions, please reach out to our PAOs, and thank you for your time. Good night.